All right, guys, I'm going to give you one more example problem. This one's a little bit more similar to the one you have to do on the Google quiz. All right, so we want to take potassium and chlorine, and we want to turn it into the ionic compound potassium chloride. All right, so think back to the steps in our last problem. Step one is we want to take this potassium and we want to change it from a solid to a gas. So this was our sublimation energy. So guys, this is going to be our step one, okay? Once we had potassium in ion form, we had to steal an electron from it. So the amount of energy needed to take, in this case, one electron from a potassium ion, this is going to be my step two, okay? All right, now let's shift our attention over to the chlorine. Now, this is the part that's going to be more similar to your homework. Okay, first of all, we are going to have to break that bond. Guys, we only need one chlorine atom. So one molecule of chlorine contains one atom. So we're going to take this energy and we are going to divide it by 2. And if you look down below, this is going to be our step 3. We're going to take this 239 kilojoules and we're going to multiply it by 0.5. We don't need a whole molecule of chlorine. We just need half a molecule of chlorine. So the amount of energy to break the bonds in half a mole of chlorine gas will produce 1 mole of chlorine atoms. Okay, so take that 239 and go ahead and divide it by 2. All right, the next step is we are going to give an electron to chlorine. And when we give an electron to chlorine, it now goes from 7 valence electrons up to 8 valence electrons. That's going to be an exothermic change. And then our final energy change is going to be the formation of the bond. So when these potassium ions and these chlorine ions get together, energy will be released and it will be exothermic. So our step one, we got to take potassium, turn it from a solid into a gas. That's our heat of sublimation or enthalpy of sublimation for potassium. Okay, so we're going to have to put in 90 kilojoules per mole in order to convert solid potassium into a gas. Then the next thing that we're going to do is we're going to take potassium and we're going to turn it into an ion. So taking electrons requires the input of energy. So to remove 1 mole of electrons from 1 mole of potassium takes about 419 kilojoules. All right, now guys, this is the step like your homework. We need 1 mole of chlorine atoms. So half of a mole of chlorine gas, when dissociated, will produce 1 mole of chlorine atoms. So we had to take that number from up above and we had to just basically cut it in half. And this will be an endothermic change. So half of 239 is about 119.5. All right, now we start to get some energy back. When chlorine gains an electron to get an octet, it gives up about 349 kilojoules per mole. And when potassium ions and chlorine ions hook up, it releases about 690 kilojoules per mole. Now, if we sum up all these numerical values, we get a negative value. And a negative value to me indicates that this is going to be an exothermic reaction and it will most likely be spontaneous. All right, guys, this is day 5. See you soon.